Welcome to HB Tuner's Ford Gen 1 Coyote Training Part 30. In this training module, we're going to break down how the Ford Spark programming logic works within all of the tables that we have available. So if you're opening up your calibration file and you're looking at all the spark timing tables that we could potentially dial in or touch, there is a tremendous amount of tables. We're going to break down how this all works so that everything is going to be straightforward and you're going to know exactly what to change as you go through and dial in your Coyote engine. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our spark timing programming within our Ford Gen 1 Coyote PCMs. Our spark timing is going to be a relatively complex type of subject. We have a lot of different tables to deal with. Looking at the spark timing programming is pretty intimidating. We're going to break down how it works in this tutorial and draw on what we've talked about and learned on in the last tutorial of the basics and fundamentals of spark timing. So that's going to be understanding, in the last tutorial we covered what the values mean in the actual spark timing table, the degrees before top dead center. We've talked about maximum brake torque. We talked about our knock and pre-ignition and why we want to avoid them, and then generally just understanding how it fits into the auto cycle in terms of the rotation of the engine and the different power strokes. That should be very clear, and if you're unfamiliar with that, definitely jump back into that video and refresh yourself before moving into this tutorial. It'll make a lot more sense. So let's jump in here and take a look at where we can find our spark timing, and then let's start breaking down how this all fits together. We need to understand the flow of logic and the programming from Ford so we can break this down and we understand when we're driving or idling or under full throttle, where we're sourcing our spark timing from, and then what kind of changes we need to make. And we're going to have the next tutorial is going to be taking a look at a live demo of doing spark timing on our Gen 1 Coyote applications, so you can see the whole process from start to finish, just so we can apply everything and make sure that you're following along. You can replicate that on your own vehicle. We will have a force induction specific tutorial later on in the training course talking about all kinds of things from fuel and spark timing and variable cam control. But for right now, we are just going to be focusing on this basic application so we can start to digest this material and understand what is going on as we're moving through the spark timing process. So let's jump in here. We're going to find that I have a 2013 Mustang GT. We're going to go into our engine tab up here at the top, and under engine, we're going to move from general over here into the Spark tab. In Spark, we have 4 separate subsections. We have an advance, a retard, we have a dwell, and we have a knock sensor. Let's go in and just break down what individually each of these mean. We'll understand how they fit together, and then we will go through some log data examples so we can see what to look for and how this all ties itself back into the actual programming for the actual spark timing tables. So there's a lot to digest here. We're going to go slow and try to go and break this down as specific as possible so you have the best possible understanding of what is going on here. Okay, let's go into our advanced tab and let's start to talk about how this all fits together. This looks extremely overwhelming. If you look at this, you see all these tables and you're probably thinking to yourself, there's no way that I could possibly tune all of this. This just seems too complex. It is complex, but we can actually break this down and figure out exactly where we're at in terms of the spark timing process and the flow of logic. Once you understand that, and once you know what to look for in the data logs, things become a bit more simplistic, and you can definitely go in and take care of the spark timing. It's not impossible. It seems like it is right now if you're getting started with this, but let's take a step back. Let's break this down into the very basic fundamentals. So first thing we need to go and understand is, let's talk about cranking over the engine. Cranking the engine, we have a certain amount of spark timing that we need to command, just as we would when the engine's driving. So we actually have a table associated with that. That's up here into the startup cranking spark. This particular table is going to command what the timing should be at in degrees before top dead center, as we talked about in the last tutorial. So all the values in these tables are degrees before top dead center. This is going to be degrees before top dead center in relation to engine coolant temperature and the air temperature. So depending on where we lie in the table, it's going to have a certain amount of ignition timing it specifies to fire off the engine in cranking conditions. Now it knows that we're in cranking conditions based on the engine speed. If the engine speed, let's say, is below 350 RPM, it's going to consider us to be in cranking mode, and then we're going to be sourcing the timing from our table here. If you're getting kickback under starting, it could be related to having your spark timing to advanced here if you've changed the values. These stock values work well. I typically don't alter them, but they are here if you do need to change them under cranking conditions. Now, once the engine fires off, it exceeds about 350 RPM, it moves into our idle spark advance. This is where we specify the spark timing for the idle conditions. Now, taking a look at our table here, let's look at our park neutral. This particular table is based on just coolant temperature alone, and then we see here left axis is coolant temperature, and the values in the table are degrees before top dead center, commanded when we're in idle conditions. So the engine knows that we're in idle conditions based on all kinds of parameters it's tracking. Usually it's going to be speed, vehicle speed, and it's going to be throttle angle. So if we're stopped and our throttle's not getting moved, we're not driving, or trying to go in and give any throttle input, we're going to be in idle conditions. This is what it sources for spark timing. Now we're going to notice a trend here. We see at the colder coolant temperatures versus the warmer coolant temperatures, the spark timing in the table is completely different. At the colder coolant temperatures, we command more spark advance because we have frictional drag from a thicker viscosity of the oil on the engine. We also have the factor of a wall wetting type of situation going on where the fuel isn't getting to the engine as efficiently as possible as we're spraying the fuel from the injector into the intake manifold going through the intake ports. It likes to stick to the intake valve and the intake port.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.